All right, let's jump right in. We're going to talk about something really cool today, a new framework that could completely flip the script on how we use AI. Think about taking the massive brain power of something like GPT-4 and putting it not in some far-off data center, but right here on the everyday devices we use. Seriously, just think about this for a second. What if your smartwatch, right on your wrist, had the power of a supercomputer? Imagine your phone, your car, all of them running AI as smart as a giant server, but instantly, no lag. That's the dream, right? But for now, it's pretty much just a dream, and there's one huge reason why. You see, the biggest, baddest AI models out there are kind of trapped. They're stuck living in these enormous centralized data centers. So every single time you ask a question or use an AI service, your request and your data has to make this long trip to the cloud and all the way back. That creates lag, delays, and it also means you're sending your private info miles and miles away. So that brings us to the big puzzle researchers are trying to crack. How do we move all that AI brainpower from the faraway cloud to what we call the edge? And the edge isn't some futuristic place, it's right here. It's the devices in our hands, in our homes, in our cars, it's all around us. And this really highlights the fundamental trade-off we're dealing with. You've got the cloud server on one side. It has massive, almost unlimited power, but because it's so far away, it's slow. Then you have your edge device, like your phone. It's right here, so it's super fast, instant even, but its power is pretty limited. It's that classic tug of war, brains versus speed. Okay, so you might be thinking, why don't we just shrink these big AI models down and stick them on our phones? Great question, but it's just not that simple. Turns out there are two huge roadblocks that make this whole idea really, really tough. All right, the first and biggest problem is a fancy word, heterogeneity. But all it really means is variety, or maybe even chaos. See, the network of devices around you isn't all the same. It's a messy mix of a powerful gaming PC with a GPU and a tiny little smart home sensor. They don't just have different power levels, they literally speak different math languages. Some use super precise numbers, others use less precise ones to save battery. So a one-size-fits-all AI model? No way. It's just not going to work. So this is the exact puzzle the researchers behind this paper wanted to solve. How on earth do you build one smart framework that can actually work across this whole messy collection of different devices? Well, the answer they came up with is pretty brilliant, and it's broken down into two main parts. First up, training. How do you get this weird team of devices, some strong, some weak, to learn together? The solution is this really clever process that lets them all collaborate on making one big AI model smarter, but without crashing the weaker devices or clogging up the whole network. So here's the play-by-play. A central server sends out the basic AI model. You can think of it like a teacher giving out homework. Now, each device on the network takes that homework and practices on its own private local data. And this is so important. That data never, ever leaves your device. It stays with you. Then, instead of sending back the entire completed assignment, which would be huge, they just send back these tiny little summaries of what they learned. The server then cleverly combines all those little lessons learned from everyone to make the main model even smarter. And just look at the difference this makes. Wow. The old way of doing this would mean shuffling 280 gigabytes of data around. 280! But with this new framework, it's just 5.3 gigs. That is a massive, over 98% reduction in network traffic. This is what takes it from a cool idea to something that's actually possible in the real world. And here's the secret sauce, really. The system is smart enough not to treat every device the same. It lets the beefy, powerful devices contribute really deep, complex lessons, while the little guys contribute simpler ones. And then, back at the server, this intelligent system knows exactly how to mix all those different contributions together to create one super smart AI. Okay, so that's the learning part. That's how the team gets smart. But what about when you need to actually use the AI to do something? That's a process called inference, and how this framework handles inference is the second big breakthrough here. So instead of forcing one device to handle the entire giant AI brain by itself, the framework does something much smarter. It breaks down a complex problem into a bunch of tiny, bite-sized pieces. It's kind of like a project team at work, right? Instead of one person trying to do everything, you get a team of specialists, and each one tackles a small part of the job, all at the same time. And of course, every good team needs a project manager, a boss. In this system, that boss is called the orchestrator. It's basically an AI coordinator. It looks at the big task, chops it up into all those little microtasks, and then, like a great manager, it assigns each tiny job to the best device available for it. Maybe your phone gets one piece, your laptop gets another, and a nearby sensor gets a third. And the results of this teamwork? They are just incredible. Let's compare it to just trying to cram the whole model onto one powerful device. This team approach cuts the response time, the latency, by almost 60%. And get this, it reduces the amount of active memory needed by over 70%. So it's not just faster, it's way, way lighter too. All right, let's put it all together. Let's look at the bottom line. We know it's faster, we know it's lighter, but did we lose anything? Is it still as smart? The answer is a big no. The final model, trained and run using this whole collaborative system, achieved an accuracy of 84.9%. Now, I know, a number like that doesn't mean much by itself, but wait till you see how it stacks up against the old school methods. Okay, this table right here, this tells the whole story. Look at the cloud-based way. Yeah, it's accurate, but it's so slow, 850 milliseconds. Now, what if you just put the whole model on one powerful edge device? Okay, it's faster, but look at that memory usage, 14.5 gigs. And then, look at our framework. It is by far the fastest at 172 milliseconds, uses just a tiny fraction of the memory, and the accuracy is basically identical. It's a total win-win-win, the best of all worlds. So, what's the big picture here? Why does any of this matter? Well, because a framework that's faster, lighter, and more collaborative isn't just a small improvement. It's basically the key that could unlock the entire potential of the intelligent edge. Yeah, this isn't just some neat trick for engineers. It's a technology that enables a whole new future. We're talking about autonomous cars and drones that can react instantly without waiting for the cloud. We're talking about personalized healthcare AI that runs on your phone, keeping your most sensitive data completely private. This is the stuff you need to build real, responsive smart cities where decisions happen in the blink of an eye, right on the street corner where they're needed. What this research really does is give us a blueprint, a practical roadmap to a future where super powerful AI isn't just stuck in the cloud, that is all around us, woven into the very fabric of our world. And that leaves us with a pretty mind-bending question to think about. When every object becomes intelligent, when your watch, your car, and your coffee cup can all learn, reason, and work together, how will our world change?